elevation and depression. So the thing with angles of elevation and depression is that they're always the same angle. So the same angle that you have to use to look downwards it's the same once you look downwards at a particular object. If the object that you're looking at was able to look back at you, the angle which you looked down would be the same angle that they would use to look up. So the angles of elevation and depression are always the same value, as long as the item or the object that you're looking at is the same thing that you're calculating from. Now, in this particular question, it says the angle of elevation of the top of a vertical tree from a man standing on level ground 25 meters from the base of the tree is 38.5 degrees. Calculate the height of the tree. So once you're doing angles of elevation and depression, you're working with a triangle. So you're going to use our triangle. So create your triangle. So not drawn to scale. So have your triangle first. Now you will start filling out the values based on the information that you're given. So the fact that this says that the angle of elevation of the top of a vertical tree from a man standing on level ground is 25 meters. So you know that the distance between them is 25 meters. So this is basically the man. So I'll use M for man. He's doing it based on a tree. So the tree top and so I use those. So the tree top, tree bottom, and the man. So that's it. Now for the 25 meters, then it says the base of the tree is 38 degrees, 38.5 degrees. So from here, looking upwards, the angle of elevation is 38.5 degrees. So the angle of elevation is at the bottom of the triangle because you'll be looking upwards. But if it was the angle of depression, since you would be looking downwards, you would have to have a little broken line here, and it's here, and you are looking down for your angle of depression. Now, when you fill this out, the question says calculate the height of the tree. So you're trying to calculate this value here. But this now takes in effect the trig ratios. So what trigonometric ratio includes this side, which is adjacent, and this side, which is opposite from the angle? So the only ratio that we can use is tan. So once you are dealing with angles of elevation and depression, tan ratio generally has to come in play. It's almost like it's mandatory that tan ratio will be used once you're trying to find the adjacent side or the opposite side once you're given the angle on one of the others. So let's use the tan ratio. So tan ratio says that tan theta must be equal to the opposite side divided by the adjacent side. So in our case, the angle is 38 degrees. So tan 38.5 degrees must be equal to the opposite side. In our case, that's x, divided by the adjacent side, and that's 25 meters. Now, you're trying to find the value of x. So that's when you cross multiply or you solve equations. So once you're good at solving equations, you're trying to solve for the value of x. So in order to get x by itself, you will multiply both sides by the denominator. So that's 25 times tan 38.5 will be equal to x. So once you multiply this side by 25 as well, it will cancel that part out, giving you a value of 1. So you will get this line. Now when you reach here, all you need to do, put it on your calculator. So 25 times tan 38.5, and that will be equal to 19.89 meters. And depending on what the question says, you will round it off to different values. So if the question says round off to the nearest whole number, you know that this will go up to 20 meters, etc. So that's what you do with these. So once you need tan ratio, angles of elevation and depression, you generally use tan ratio. So let's take another look at another example which requires you to calculate the values of two heights and work the difference between them. So in this example now, it says a surveyor stands 100 meters from the base of a tower on which an aerial stands. He measures the angle of elevation to the top and bottom of the aerial as 55 and 51 degrees respectively. Calculate the height of the aerial. So in doing this, as I said before, draw your triangle first. Alright, so that's one triangle. So here would be from the tower to the person, the surveyor man. So X is the surveyor and the tower is here. Now it says that the man or the surveyor would have measured from the top and bottom of the area. So this is the aerial is on top of the building. So there, and then you'll have another piece up here, and you will just draw your triangle to come right back to where the man is. So both of them will be there. So now it says that from the top and bottom, so 55 degrees is from the top of this surveyor, the aerial, so that's a 55 degrees. And then it says the bottom part is 51 degrees. So that means this part here, the inner part only, is 51 degrees. Then it says calculate the height of the aerial. Now put in your 100 because it says stands 100 meters from the base. So from the base, 100 meters. So now you need to calculate the height of the aerial. So how can you calculate the height of the aerial from being told the height of the building and the angles of elevation? It's simple. Calculate the angle of elevation from the person to the top, and then you'll calculate from the person to the bottom of the aerial, and then you'll be able to find the measurement for this little piece here. So let's calculate it now. So angle of elevation. Before I told you that tan is the way to go because you have your adjacent side and you need your opposite side. So let's work it out. So you'll start by using the value that says tan. So you already know that it's tan theta. So we are going to start with the 55 degrees. So tan 55 degrees is equal to the opposite side. We'll call it K in this case. Or let's call it A because we are trying to find the area. So A. So A is the opposite over the adjacent side, which is 100 meters. Do the calculation, so that's 100 multiplied by tan 55 must be equal to A. So tan 55 degrees multiplied by 100 will equal to 142.81 meters is the first value of A with 55 as its degrees. So from the person to the top, the value that it gives you from here to here is this amount. Now you need to now find the second one. So tan 51 degrees is equal to the opposite side, which is A again, over the adjacent side, which is 100 meters. So tan will have 100 multiplied by tan 51 is equal to our value of A. So let's calculate that now. So tan 51 times 100, that gives you 123.49 meters. Now, so this tan here gives you the value from A, from the T here to the bottom here. So you're basically saying that from here, this part is 123.49 meters. And then now, based on the calculation, it means from here to where T is 142.81. So it's now asking you, what is the difference between moving from this point here to go up there? And the only thing you do, the word difference means subtraction. So you'll subtract the bigger number, the smaller number from the larger value. So it will be 140. A is officially equal to this value here, 142.81 meters, subtract 123.49 meters. And that will be equal to, so 142.81 subtract 123.49 meters, and that will be equal to 19.32 meters. So the value of the aerial, the height of the aerial is 19.32 meters, and that's what you do. So once you're finding the angles of elevation, your formula to go to generally will be tan theta. Once you are given the opposite side or the adjacent side, the only way you can calculate the missing value is by using tan theta. And that's the trig ratio that falls with angles of elevation and depression. So I hope this video would have helped you understand and calculate angles of elevation and depression when you are trying to find the heights of items, or if it's just a single calculation. So tune in again with Mr. Brown where I explain other mathematical concepts.